Welcome friends once again to our NPTEL MOOC module on health economics. We are presently explaining the week 8 on the theory and principles of economic evaluations. We already discussed 2 lectures on it, and this is our third explanation on the principles of economic evaluation. We are trying to give you all possible details to understand the principles of economic evaluation. So, especially in the previous 2 lectures, we learned about least performed economic evaluation principles. Those are CCA and CMA. CCA stands for cost consequence analysis, and CMA stands for cost minimization analysis. Also, we discuss about the 3 most performed method. Those are CBA, cost benefit analysis, and other 2 on cost utility analysis, etc. We will be discussing that, but most important one is CBA. Within each of these, we discuss their definition, objectives, features, use of this principle with their respective examples, their advantages and disadvantages. In this lecture, we will learn in detail the remaining 2 most performed full economic evaluation, that is, as I already said, that is cost effective analysis, CEA. So, we will start by the CEA in detail, then in the next one we will introduce the last method. So, the economist recognizes that health economics involves some cost and benefits. Those can be measured, but not in monetary terms, called incommensurable items, such as hospital service, where measuring patient satisfaction is the most important direction. Some others known or suspected to exist but cannot be qualified at all are also called intangible or intangible items. These are dealing with in some cases called mental illness issues, where it's purely intangible and difficult to measure. This is where the CBA fell short. That leads to the development of few other principles of economic evaluation that are highly performed in health economics evaluation. So, they are indeed, as I already said, it's called CEA, cost effective analysis, and cost utility analysis. Okay. So, now starting with CEA, we will just compare with the CBA method which we discussed, and we will find out why this is different. In terms of their definition, CEA is a form of comparative economic analysis that evaluates 2 or more policy alternatives in terms of their relative cost and outcomes. We are also referring the same author, Turner et al. Here the outcomes are measured in a single natural unit. Okay. That is, suppose life years gained, number of disease cases, etc. The rationale behind this method, I stated earlier that it is difficult to measure benefits in terms of money similar to cost, like we did in CBA. In practice, the comparison of cost and benefits in different units is not straightforward. So, is there any theoretical basis for such comparison? Yes, the answer is yes, because the theory of production efficiency provide a theoretical basis to this comparison. Then what is this theory of production efficiency? We will be discussing here, and also some of this direction we already address in unit number 3, and where we discuss about isoquant curve that shows a mapping of the inputs to produce the same output, different combination of input to produce same output. Usually this is measured in physical units, and another requirement is called isocost curve, and that's really shows a different combination of inputs that can be afforded given a budget. This is usually measured in monetary units. Now, in this one, even in our efficiency chapter, we have also highlighted this diagram. through their isoquant and isocost. And in the efficiency chapter especially, we are discussing or in unit number 10 we will be discussing on even in detail about technical efficient points, how it is measured, what are the different methods. However, the basic fundamentals of this is through its the efficiency frontier, which can be projected through the isoquant and isocost line. Especially isoquant is the benchmark. So, isoquant identifies technical efficient points, the maximum output that can be produced given the inputs. That is basically the efficient frontier. And the isocost identifies the allocative efficiency. Okay. In this diagram, it is across n and d. You can just see starting from n till d. Okay. So, this is the line. You can just have a check, and this gives a set of input prices. And basically, in this efficiency point, the answer is that where for a given set of input prices, it is not possible to produce extra without extra cost. That is the best or the minimum most cost point. So, overally at point E, due to the cost as well as allocative efficiency and technical efficient points, you will find the overall efficient points, and this is tangential and to the point end, and the point is defined as E, okay, and forming the equilibrium. Hence, it is theoretically and well established that even though not straightforward, it is possible to compare cost and benefits in different units. Moreover, similar to the theory, this method, that is CEA, also tries to identify where more benefit can be generated given the cost intervention, or how lower cost can be achieved for the same benefit. But in practice, there are many situations where we wish to compare alternative interventions. However, it is not possible to keep either cost or benefit constant. In this case, the solution that economists suggest is cost effective ratio, okay, with the implication that lower is better. We will understand this with appropriate example. So, here is the point. We are actually concerning the study by Turner et al. That assesses the cost effective of different chlamydia screening policies in England. It's referring to the uh, policies for healthcare, and they compare the following strategies. First strategy, second and third we will just explain. In the first one, the current screening strategy out of that's basically called NCSP, the National Chlamydia Screening program. And in the second one, that's called new intervention, and third one is another intervention of the program to evaluate the program of that NCSP. So, the new intervention strategy one is through increasing or increase efficacy of partner notifications. So, partner notification usually from 0.4 to 0.8 partners for index case. We will give you that example. And another intervention is called new intervention, that is strategy number 2, where increased screening coverage for men, okay, usually from 8% to 24%. As per the author's calculation, we are just citing for better clarification. Further, this is calculated for direct cost of provisioning each of these strategies and the number of infection treated. We will actually see this and how direct cost and their number of infections are actually treated. We will just find out. Cost for infection treated, we will take the cost benefit ratio with each strategy as shown before. So, the program is NCSP, the total cost and the cost per infection treated is mentioned, total cost in £1,000,000. So, now as per the example, the increased partner notification and their cost per infection treated is also given, and the screening specific for men and their details are also mentioned in this example. Now, we will calculate as per the Turner 2010 suggestions or conclusion. Here, increasing the efficacy of partner notification was cost effective. Okay, you can just see this is 49.57, but increasing the screening for men was not as compared to NCSP. So, even instead of a simple cost effective ratio CER, when the authors use incremental cost effective ratio, that is called ICER, okay, the result really is interesting. We are going to just show it to you, where the incremental one is basically delta C by delta B instead of only C by B. Okay. So, delta means cost 1 to cost B, and B stands for benefits. This is mentioned here. So, the additional this means the additional cost per unit of health gain is actually presented. Now, you can just see the results. The same example is on the first table. On the second one, we are just trying to find out ICR and other details. So, first one is basically increase partner notification versus NCSP, and the second one is here. The second one is here, increase screening for men versus NCAP. So, the incremental cost, so the change basically the change, that means from the absolute number 49.57 minus 46.26, you will find the change is here presented as 3.31. Similarly, the second one 69.17 minus 46 27. So, you will find the change. Okay. And now, the effect, the incremental effect is also presented here. Now, the total infection treated and the differences you can also find out. So, the change from the third one is also given, all right, for comparison. Okay. So, the changes are quite important here. Even ICR suggests that the partner notification is more cost effective. You can just see, especially for the partner notification, we already said as per the absolute figure as well, their incremental cost is lesser than that of the screening for men. Okay. So, now we will also answer. Let's answer this example as well. If the intervention A cost 10,000 rupees, and the effect, that is I mean they extend the life by 5 years, while in intervention B the cost is of 8,000 rupees and the life extended by 4 years because of the intervention B. What is the incremental cost effectiveness ratio ICR for intervention A compared to intervention B? So, there are these options, you can just see which option is really good. You can try this answer. I'll just clarify and give you certain hints. We know that the cost wise, we know that the cost is it has to be answered through delta C by delta B. Okay, so this is C1 minus C0 divided by B1 minus B0. All right. So, in this case, we know that the life extended by 1 year. So, the effect is actually 1. So, in the denominator you will find in the denominator you will find 1, okay, and whereas the numerator it is actually the difference, that is 10,000 minus. So, 10,000 minus 8,000, so 2,000. So, here the answer would be accordingly derived. So, 2,000 divided by 1, it will be 2,000. So, you can check the different point. If it is, you can check C1 minus C2 as per your convenience, B1 minus B2, whichever the starting point you take, so you have to follow in both the cases accordingly. Okay. So, now Can you also answer this question, which is little different? Let's see. The cost of intervention A is of 5,000, and this leads to 50 life years gain, and the cost of intervention B is of 4,000, resulting in 45 life years gain. Now accordingly you can calculate the cost effective ratio, but now just see the difference. It is not incremental, it is only cost effective ratio. Okay. So for both intervention and determine which one is actually more effective. The previous one we discussed about ICR, the example. In this case it is CER. So there are all these options we can find out, and all which one would be more relevant. So CER for intervention A is so per cases, that means 5,000 divided by 50, it is actually 500, and so 100 sorry, 5,000 divided by 50, it is of 100 for life year gain. So this is average a cost as per the intervention A, that is 100. So 100 we have calculated in this case. Okay. And CR for intervention B, it will be of course of 4,000 divided by 45. Okay, so that's precisely around 88.89 per life years gain. Hence, out of these two comparison, you can just see that intervention B is more effective because its cost is lesser. On the second one, let's see what really happens. So far as CR is concerned, for the case A, if you just find the reverse figures, I think it's uh, not may not be correct. So similarly, other options are there in front of you. You can find out which one is really the correct option. Okay. So I have just given certain hints to it for this question. Others you can find out. So and then in the query lecture, we'll have a live session as well. You can raise your voice. So we'll just present here about some of the limitations of the CEA model. It's already mentioned the CEA measures health consequences in single natural unit, which you have just seen, like cases avoided or life years gained. However, it is indeed difficult to really compare studies investigating intervention that target different diseases or different stages of healthcare, as health consequences will be exposed in different units. This is really limiting its potential use for informing policymakers. Moreover, choosing and comparing even between different units of measurement of effect is also difficult to specify. This limitation can be understood by an example. We will just mention, suppose we have a comparison that involves a treatment that prevents heart disease. Okay. All right, so preventing heart disease, we are just presenting in detail at this moment. A treatment that prevents heart disease, and in 1 out of every 20 cases of the disease, a person suffers heart attack, and half of those who suffer a heart attack is indeed dying, or they die, leading to an average loss of 5 years of life. So now we are giving multiple information at this moment. The treatment cost for this is 50,000 rupees to prevent 20 cases. Okay. So what different results do we get here under the CEA assumption that health consequences are of single natural unit. This requires some mathematical calculations, and that goes like this. There are all variety of options needed. Cost is of 50,000 cost per 20 cases, which I already said. Okay. And it is of rupees 2,500 for case prevented. So 50,000 divided by 20. This ratio indicates the cost required to prevent one case of heart disease, and this is actually money per case prevented. Okay. money per heart attack prevented can also be calculated. Okay. In that case, that will be 50,000 for one heart attack, that will be rupees 50,000 case. And this ratio measures, this is the one, this ratio measures the cost of preventing one heart attack. Another one is direction to understand this question is, so money per death averted as well. So, we know that 50% cases, here half of those who suffer heart disease die. So, 50% it has the death cases. So, it is divided 50,000 per case is the cost divided by 0.5. So, that can be averted. So, that means 1 lakh per death averted. The cost for this is 1 lakh. This ratio quantifies the cost to avoid one death. Another one is called money for life saved. So, in that case, for life saved, we know that that should be saved for 5 years, I mean, and loss for 5 years we have already mentioned. So, in this case, its death aversion rate is 0.5, half of them aborted, and for till 5 years. So, years of life saved, this is what we have mentioned. So, it is the cost of it is of 20,000 rupees per life saved. This ratio indicates the cost of saving 1 year of life. Can these results be obtained using ICR? We will just mention on these differences. This requires some mathematical calculation which we did it, and different measures of effect can lead to different interpretations and results in CEA. Let us break down each of these calculation and their implications. We just did it. Okay. And so, we will just explain once again what is these cases, this how these can be clearly interpreted, and these are the results. We will just mention here, starting with rupees 2,500 per case prevented. This ratio represents the cost required to prevent one case of heart disease. It is a useful measure if the focus is on preventing the cases of the disease regardless of their severity. So, now this is what is not clearly addressed. Okay. It says basically the focus is on preventing cases. And second one is here this ratio quantifies the cost to prevent one heart attack, and it is relevant when the primary concern is preventing heart attacks, especially if they are life threatening. Here related to the 1 lakh per death averted, where the focus on the severe outcomes, that is death, and measures the cost of preventing it. Okay. And the last one, that is 20,000 rupees per life saved. This evaluates the cost to save 1 year of life. It considers the broader perspectives of saving years of life rather than specific events. Okay. So, the conclusion of this particular example is on the choice of measure of effect is critical in CEA, especially when comparing interventions for the same disease. If one intervention is better at preventing non-fatal heart attacks, while another is better at preventing fatal attacks, the choice of effect measure is crucial yet practical, practically difficult to answer. This difficulty leads to the or led to the development of specific form of CA, that is which we already started with another category, that is in short called cost utility analysis, or CUA. There are other forms of CAs available as well, like distribution CA or extended CA, that are used for priority setting. So, if you are interested, you can see the references which I have cited, and will be useful for your reading. So, what we dealt in this lecture, in short, let us clarify, explain once again in short. Although the cost benefit analysis is the most widely used method across different sectors, but the CEA is most widely used in healthcare. You can just take a note, this is most widely used in healthcare. Under CEA, outcomes are measured in single natural unit. Theory of production efficiency provides a basis for CEA. This tends to compare cost and benefits of different units. Cost effective ratio helps in deciding the best policy intervention. There are two important limitations as well. It is difficult to choose the best measure of effects, since effects can be measured in a different ways, and this cannot compare the interventions for two different health issues. Issues in CA led to the development of cost utility analysis or CUA. Okay, so in the next class we will be discussing the CUA and its features, the thumb rules for CUA and the specific example and those used in practice. So these are the readings I think will be useful. We have mentioned Turner's et al. In our specific page. You can also follow. We have also given their article link DUA file, and I think it will be highly useful for you. With this, I think I should stop here. I look forward to your participation. Thank you.